As you probably noticed on the slides, I have a couple of QR codes. One is for a GitHub project that I've been putting together for this event that kind of goes over a very basic C++ setup for a Node project, and similar kind of thing to the slide deck that we have here. So you can refer to it later. It's also wonderful because if you see this later on the YouTubes, if that is what is happening, then you will be able to find it fairly easily. All right. So as was mentioned, the question was posed, who am I? And I'm proud to say 24601. Oh, wait, never mind. This is what I really am. Software engineer, Dynata, joined not super long ago. That last bit is a bit of a point is a bit of a disclaimer. I am not going to pretend to actually be a master at C++, but I will pretend to be one for your enjoyment today. So, we have a scenario. You maintain the most popular dad joke generator in business at paternal universal networks. A sudden influx of babies being born has caused a spike in your app's usage and causing performance problems as dozens of new fathers scramble for the best dad joke generator west of the Mississippi. You're tasked with fixing the performance problems, and through the extensive research you put in by half-skimming the first article Professor Google gives you when you look for solutions, you settle upon adding a native Node add-on to the server as your best option. So, you start development and discover that there are thankfully only a couple of minor things that you didn't account for. Just a couple, though. Not too much, you know. Nothing intimidating at all. Well, okay, so maybe a little bit more than a couple. But I mean, you never know what's gonna happen. Like, I mean, this all seems fine. Or, this is why you're here, right? Okay, well, enough seriousness. Now let's get into the real thing. So, we have Node add-ons. That's the term for C++ built extensions to Node. Essentially, what they'll show up as is a shared object or dynamic library. The typical extensions you'll find there are SO or DLL or dylib, depending on your operating system. But it's usually put as .node. You'll find some NPM packages actually use these as well, but it's not as common a thing that you'll find anymore, I think. The API that you'll be using for it is called NAPI, which is short for Node API, and there's a link here for on the slide deck if you want it. And essentially, there's another package that you could potentially use called nan. It has nothing to do with not a number, just so you know. It actually stands for Native Abstractions for Node. And what's cool about these Node add-ons is that you can require it directly in your common.js file. But what if you have VSM? Well, in that case, you can't really require it. It'll need a DL open call, which actually is what require does under the surface. But in the example I'll be showing you today, I can show you where you don't actually have to explicitly call DL open. But if you're trying to use it in ES module, that's what will happen. Some quick examples of different packages that use it. Things like GPIO operations on IoT, which kind of are at the system level. You also have IO serial port or IO through serial ports with C++ bindings. Keytar, which though I know it also is related to an awkward keyboard plus guitar combo, actually is really cool. You can actually work with system keychain. And many of you who've been in web development for several years probably have also experienced this Node Sass one, which thankfully was deprecated because of all of the problems that was causing. But now Dart Sass is the new right thing. Okay. I actually used this at one of my previous companies for a project. Essentially, it would take a background image kind of like this, and it would self-build a mosaic when people would submit images. So essentially, you might have something that looks a little bit like this after several images have been submitted. The idea is that it would essentially go in and take the average color for any of these images and try to match it somewhere within the actual original background image. And then it would place it wherever it would make most sense. So, as such, when I found out that it was working, it was great, but it was a client-side only app. Then I moved it to the back end, which makes more sense because if it's going to be at something like a venue, you probably don't want it to be built in everybody's browser. That sounds like a bad idea. But then there was also a problem with the performance of it, and so I created a C++ add-on that essentially did all of the calculations in the C++ thread and came up with something like this. A later test render, whatever, looked kind of like this. It did have a little bit of the original mask on it just to give it a little bit of a better idea. But yeah, so in essence, that was one of my favorite things that I did, even though it was doing C++, and I am not a C++ expert. Anyway, so let's take a look at that project that I mentioned. I'm going to close all of the tabs in my thing, and let's see. Everyone can read perfectly what's on the screen, right? Okay, great. I'm glad that everyone's on the same page with me here. Okay. So this is just a very simple example of it. And I have a couple of things to note. I tried to make a fairly decent README. By the way, I'd suggest you take a look at it. Yes. It's got some fairly decent setup instructions, and I was able to test it cross-platform. So if you run Linux, if you run Windows, if you run Mac, it should work on all of those platforms. But I also made sure that it would also, like, for instance, be accessible with just NPM, with PNPM, and with Yarn. All three of those should work. The latest one has the ability to do stuff with debugging, and I was kind of hoping to do more, but I ran out of time either way. In any case, we're essentially going to look at this code, this very, very simple code that essentially has this C++ file being called and run. So, essentially, you can see that I am in this common.js file, we're just requiring the actual node add-on. Because of the fact that you can actually build for release or debug, so you can actually debug this project if you're using the right tooling for it. I'm using VS Code, as you can see. But essentially, we have all of this that you have to do in order to get it in. Again, you just really required, and that's it. That DL open thing that I mentioned is handled under this require. Now, with the modules, you don't really have the require functions, so we have to make it ourselves. So essentially, we just pulled from module the create require function, created it based off of this current file, and then we can require just like we did the other one. Pretty simple, pretty straightforward. What it will look like is essentially module.exports. In this case, what you will get back from this is whatever's on the exports of it. You'll see a similar kind of nomenclature here with exports, as you would see in a common JS file. And then you have to explicitly say, on this exports object, I want to set the member of doThing as a method to do the thing, which we created as a function up here. Put simply, all we have to do now is run our project. Woohoo! Well, that was easy. Well, now you're all experts. I'm done. Now, there are a few different things to note about this project too, is that you need to start kind of getting to know about JIP. Technically, there might be ways to get around using JIP in general, but JIP is supposed to sort of be the tool. Node JIP is what you might have seen, is the tool that you might want to use to make it a little bit easier to manage all of that. It takes care to include all of the node files and stuff like that, so you don't have to. For instance, like you could include specific directories if you want to. I don't actually have any of these in this particular project. You can specify what the names of the binary is going to be called. In this case, I just left it my node add-on. By default, I think it's just node add-on or something like that. You can specify specific variables that you can pass in through the command line, kind of like we have here, when we are trying to configure for development versus production builds. And then you can also specify per operating system. Now, to note, you will have to make sure that the build tools are correct for your own environment in order for it to work. So, specifically, oh, wait, no, let's go over here. Yeah. Specifically, Windows, you'll need the Visual Studio build tools. By default, if you're installing the node from the installer, you can actually install these up front. If not, then you'll have to just look it up and install it that way. On a Mac, you have Xcode, which I hate how that jumps back over here whenever you double click on this, but that's beside the point. Xcode will take care of installing the ceiling CLI, which is the thing that will build it for that. And on Linux, you have good old GCC. And if you want to use the debugger, then GDB is also going to be needed. If you need to, there's also C++ libraries that you'll have to add, but at this point, you'll probably have to be an expert at that anyway. But yeah, essentially, that's what all it takes. You can see with the package JSON I put together that we have things like building, we have this configure step, which that seems to be needed for some platforms more than others, but it doesn't hurt to just run it. When it builds, it uses NodeJIP to run it based off of what it finds in here. It'll take care to find the compiler and then build it. However, sometimes it's better to rebuild or clean it, and that's going to be needed. One other thing that I was going to also show in my example, but I didn't get time to, was testing. One nice thing about testing, I can just say real quick while we're here, is that if you want to test the node add-on, you have the ability to use Jest or any other kind of node-based library in order to test if you want to. But I didn't get around to do it. Honestly, I've kind of fallen in love with vtest, but we can talk about that another time. Anyway. But yeah, this is essentially all that it is. I'm going to do the configure. And then you can kind of see what that looks like. Just sort of runs through the script. You see a whole bunch of output and it says it's okay. If it says okay, then it's good to go. Similarly, you can do build. And you can see that it already takes care of that. It grabs all of the inputs that make sense. And there you are. You have a brand spankin' shiny new add-on. So one last thing to note is that this build folder will be created automatically based off of whatever the development versus production build that you want to make. It'll go to either debug or release, not respective of the opposite. And yeah, that's about it as far as this simplistic project is concerned. However, I would be willing to have any, or to take any questions about it at this point. Anything that piques interest. Yeah?
So do you typically, if you're developing a library, you typically need to have access to development environments across all three platforms? Make sure that you get everything correct.
That is a good question. So that you can hear it in the video afterward. The question is, do you need to have access to all three kinds of main development environments in order to be able to actually develop add-ons, packages, and that kind of thing? Well, we'll go and run over to a slide that I might just have mentioned that about. Essentially, one of the things that you'll notice is down here, this last one, is that you will need to be concerned about cross-platform compatibility. One of the reasons why Node SASP, for instance, was using, would just have it build on your machine is because they don't have to necessarily have it pre-built for you. They don't have to make any assumptions about your environment prior to it being on your computer. And for that matter, there's another question about distributing the add-on in the first place. For instance, what if I need to actually distribute the add-on through NPM? How am I going to approach it? Are we going the Node SaaS route with building on the consumer's device? Nice thing about that is that if it builds, you have more or less it's more or less guaranteed that it's going to work. A lot of times, if it's not building, it might be because you either have a different version of Node or your build tools aren't quite ready to handle it. But it's not so great because of the fact that because of Node version requirements and other stuff, it's not really easy to ensure that it actually is going to build on somebody's computer. Similarly, precompiling it, like you mentioned up there, making sure that it works across environments, it's probably going to be the case that you will want to have one of each of the different platforms. With me, I have a MacBook, I have a Windows computer, and on Windows, I have the Windows subsystem for Linux. So I was able to actually make sure that all three were covered fairly easily. But still, it's a little bit frustrating in that regard as well. But I mean, when it comes to that, you also have to think of other things like the install size. Do you want to use NPM to distribute it? Do you want to have a per platform package? Like I know ESBuild, for instance, actually has a per platform package that installs based off of which platform you have. It actually works a little bit differently and doesn't actually use a Node add-on, but it's a similar kind of concept for that too. But yeah. Yeah?
Could you explain, this is, I think, related, but maybe a little bit different. Could you explain what Node.jip is?
Absolutely. Node.jip, the question was, what is Node.jip about? It's essentially a build tool that was built by the Node team to help with building these Node add-ons. It sort of orchestrates everything for you so you don't have to really do it yourself. You don't have to figure out, okay, how do I make sure that I'm passing the right variables or right arguments into the compiler script in order to get it to work. Or, for that matter, you can say, I want these libraries, and since Sealing, since GCC, since MS Build, all use different formats for pulling in libraries. It can help with some of the cross-platform compilation as well. Also, if you do anything with Node.jip, you'll actually find that if you put the binding.jip like you saw in here, you'll actually have a badge inside of GitHub that says, oh, this has Python in it. And in reality, it's just one file that has a little bit of Python in it. But either way. Yeah? I didn't find one quite yet. The research that I've seen says that because of the way that C++ is, it generally is going to be something that can be more performant than the JavaScript. So therefore, that's part of the reason why, for instance, Node SAS was doing it in C++, because it's faster than trying to pull and read things, turn it into an abstract syntax tree and everything inside of JavaScript. And so that's part of the reason why they were going for C++. But that's not always going to necessarily be needed for your use case. Node is pretty fast already, so there's not going to be much of a reason to opt into C++ over just Node, unless essentially everything matters on performance. But even then, there's a little bit of trickiness when it comes to communicating between the C++ layer and the Node layer. So you do have to be mindful of that. Trying to jump that gap too much probably isn't a good idea. Any other questions that we have? Yeah.
So you were saying you run any node tests on any C++ tests?
Yes, you should be able to do that. It won't probably run inside of Node itself. But I mean, like if you're trying to do a poor man's unit testing setup for it, then you could probably use something like Jest. But yes, you should be able to do it. In theory, most anything C++ should work with these Node add-ons. So that should include the unit tests as well. Most of what I have personally tested with has actually been using the JavaScript to call the C++, because in my use case, I didn't really care as much what happened over in the C++ world as what the output was itself. So, good question. Any other questions? All right, so I'm going to just go over one last thing. You can clearly tell that I made the slide before I made the template, so it's very readable in that top right-hand corner. But essentially, I had some interesting thoughts about weird and wacky things you could do with C++ Node add-ons. Now, I also put a little bit of a disclaimer in there that I'm not entirely sure how viable this really is, but I want to try it out anyway someday. Like, for instance, make an interoperability layer between other languages like Python, Ruby, Java, Kotlin, C#, Rust, etc. So you can further complicate a code base. You can write a game mod using JavaScript. You have the ability with these Node add-ons to be able to call functions in either direction, either the C++ functions inside of Node or the Node functions inside of C++. So in theory, as long as you have the ability to build toward that target, you can totally do that. There are some similar sort of things that I was mentioning up there about some other weird and wacky ideas that you can maybe play around with if you really, really want to. But I am just about out of time. Anyway, you can tell that I had my slide deck perfectly ready, but I'll add my contact information later, so don't worry too much about it. Again, we have the links to the slide deck and to the GitHub project if you want to go ahead and play around with it. My plan is to, while I'm still working on it today, go through the GitHub project and try to add some of those things that I mentioned, such as a simple unit test setup and stuff like that. So other than that, thank you so very much.